do we know about the solar system, this group of 9 planets that circle the sun? We know things move. They spin, circle, and speed through space. We know they grow, shrink, crash, and explode. We think we know how old the solar system is, and maybe even how it formed. We also understand some of the forces that keep the solar system working. What's in the solar system? The sun. Solar means sun. 9 planets, including Earth, that circle the sun. More than 65 moons and a number of rings that circle 4 of the planets. Countless asteroids, which are small chunks of rock and metal that circle the sun like tiny planets. Comets, which are ice balls mixed with rock and metal dust. We see them once in a while. Waves of energy and particles and unseen forces such as gravity that help make things work. A variety of space gases and dusts. And space. Lots of space. Our solar system stretches across trillions of miles or kilometers of space. So our solar system has lots of different parts. They are tied together by the sun's gravity. Cosmologists, scientists who investigate how the world formed, think the solar system started developing about 4.5 billion years ago, near the edge of a group of billions of stars called the Milky Way galaxy. Here, a large space cloud of gas and dust, called a nebula, began swirling and contracting to become smaller and tighter. As the nebula contracted, particles of dust and gas condensed, like drops of rain in a thundercloud. Soon, another force helped draw the particles together into clumps: gravity. Gravity is an unseen force that pulls one object to another. On Earth, for example, gravity pulls an apple that falls from a tree to the ground. While the solar system formed, for hundreds of millions of years, condensation and gravity pulled nebula gas and dust into an ever-tightening sphere. When the sphere was more than 1 million times larger than our Earth, heat and pressure inside started a chain of nuclear reactions. A new star, our sun, began to shine. Some leftover gas and dust remained nearby, forming small swirling clouds that circled the sun. Eventually, these clouds packed together, in much the same way as they had for the sun. The new masses, too small to cause nuclear fusion, became the planets of our solar system. Gravity not only helped build the solar system by pulling gas, dust, and other space debris into spheres, gravity keeps it together. Without gravity, planets would fly away from the sun. One law of gravity states that bigger objects have stronger pull. The sun has 99% of the solar system's total mass. Its powerful gravity holds the planets in orbit. But if gravity were the only force at work on the planets would fall to the sun like an apple falling to the ground. A second force, called inertia, prevents this. Inertia keeps things moving in certain ways. For example, a ball you throw in a straight line will continue straight because of inertia. In space, inertia will carry a spacecraft in a straight line forever, unless another force such as gravity or rocket engine thrust changes its direction. Inertia tries to move planets in a straight line out into space, away from the sun. But gravity holds them in. Fortunately for each of the 9 planets, gravity and inertia are in balance with each other, and the planets go round and round the sun. The planets also spin round and round their axis. Inertia helps keep spinning objects spinning. Our planets have probably been spinning ever since they formed from a spinning nebula that was on a spinning galaxy. Let's look a little closer at the sun. Well, not directly at it, because that can cause blindness. Our sun is a medium-sized star made mostly of hydrogen gas, like the nebula that formed it. The sun produces heat and light through nuclear fusion. Deep inside the sun, immense heat and pressure cause the hydrogen atoms to collide so hard they weld or fuse together. The fused hydrogen atoms make a different kind of gas, helium. The new helium atom, however, weighs less than the 2 hydrogen atoms before fusion. What happens to the missing hydrogen matter? It changes into energy, an amazing amount of energy. We can see and feel some of the light and heat energy on Earth, 93 million miles, 148 million kilometers away. The planets can be divided into 3 groups. First, there are 4 inner rocky planets. Second, 4 outer gas giants. And third, and farthest from the sun, Pluto. Pluto is neither a rocky nor a gas planet. It's one of a number of small pieces of the solar system, such as comets and asteroids, that remain somewhat of a puzzle. Let's turn to the inner rocky planets for a moment. These include Mercury, Venus, Earth, and Mars. All the rocky planets are small and have crusts of rock. These planets are also denser than the outer planets. That is, a bucket full of a rocky planet weighs more than a bucket full of a gas planet. The rocky planets all appear Earth-like, so they are sometimes called the terrestrials. Terrestrial means Earth. Mars is the farthest rocky planet from the sun. Mars might have, or at one time had, microscopic life similar to Earth's. Beyond Mars lie the 4 gas giants. These are enormous spheres of gas such as hydrogen, helium, and methane. Gas giants have deep, swirling, poisonous atmospheres which give way to slushy oceans of frozen gases. The planets don't have solid surfaces like the rocky planets, though deep inside may be layers of hard, frozen gases. Each gas giant has moons, rings, or both. The closest gas planet is Jupiter, the solar system's largest planet. It's 1,400 times the size of Earth. Next is Saturn, which has spectacular rings that are thousands of miles or kilometers wide. Then there is Uranus, which leans over so much its axis points directly to the sun. The last gas giant, Neptune, is so far away, its sunlight is more than 1,000 times dimmer than on Earth. Beyond Neptune lies Pluto, our smallest, most distant planet. It's 40 times farther from the Sun than Earth. This cold chunk of ice, rock, and metal may not have formed the same way as the other planets. Pluto also has an oversized moon called Charon and appears to share its orbit area with thousands of newly discovered small objects called Kuiper Belt objects. In addition to Kuiper Belt objects, a couple of other groups of small pieces orbit in the solar system. These include asteroids. There are hundreds of thousands of asteroids, which resemble miniature planets ranging in size from a peanut up to nearly 600 miles or 1,000 kilometers across. Most asteroids circle the Sun in a belt between Mars and Jupiter. Some astronomers believe asteroids are pieces of a planet that could not pull itself together because of the strong pull of Jupiter's gravity. Many scientists also think an asteroid hit the Earth 65 million years ago and helped cause the extinction of dinosaurs. Once in a while, a comet comes close to Earth, too. Comets are famous for bright tails millions of miles long. However, the head or nucleus of an average comet is only about 15 miles or 20 kilometers in diameter. As the nucleus approaches the Sun, it forms a glowing coma, a few hundred miles or kilometers across. The spectacular tail that follows is made of escaping dust and gas that look on fire from the sunlight they reflect. Comets mostly stay far beyond Pluto in an area called the Oort cloud, where there are billions of them. Comets we see have been knocked out of the Oort cloud. Somewhere on the outside edge of the Oort cloud, we meet the heliopause. The heliopause marks the end of the Sun's gravitational grasp and the end of the solar system. Our solar system is both simple and complex. The basic concepts of gravity, inertia, and even nuclear fusion are fairly easy to understand. But uncovering the details of how and why these things work will challenge scientists far into the future. Our solar system spans trillions of miles or kilometers. Still, it is just a grain of sand on an immense beach that makes up the Milky Way galaxy, which in turn is surrounded by countless other galaxies and endless oceans of deep space. Amazingly, the same forces that make our solar system work across it all. Let's take a few minutes to review some of the things you learned in this video.